Hello everyone. Am I audible? Please tell me in the chat if I am audible. Okay, please let's wait for few minutes. Let's let people join in our session. Then we'll start our session for today's Job-A-Thon solution. Okay, let's start then. Okay. So this was our first question. Can you sort the array? Okay, let me take this screenshot of this. So what's the first question asking? Can you sort the array? Okay. So you will be given a binary array. One array will be named array, another array name will be frozen. Okay. So both will be contain binary numbers only. Binary numbers. Binary numbers. You are given two arrays, array and frozen of size n. Both size will be n same. Len of array will be equals to len of frozen. You can swap elements at indices I and j, where I and j value will be greater than equals to 0 and less than n. And you can swap only two elements if only frozen of I and frozen of j equals to 0. What does it mean? You will be given some value in the frozen array, and you can change the value of this index and this index only if the value is 0. Otherwise you cannot swap the elements. So condition is only if frozen of I and frozen of j is 0, then only you can swap these elements. Otherwise you cannot swap. Got the question? Nice, Dhruv. Okay. So what we want to determine is that whether it is possible to sort the array in ascending order or not using the number of swaps. Okay. So we have to sort the array. Let's take an example. So array is 0 1 0 1 0 1 0 1 double 0 1, and your frozen array is 1 0 1 triple 0 1 0 1 triple 0 1. So can you tell that whether it is possible to sort this array in ascending order or not? You have to return a Boolean answer, Boolean value, either true or false. Okay, your return type is true or false. Understood the question? Okay. So in this, if at this place, let's say In this what we are given, we can swap elements at indices 1 and 5. Let me take the indices 1, 2, 3, 4 and 5 and 6. So here at indices 1 and 5 our value is 0 and here our value is 1. So what if I swap this one with this 0? So here our value will become 0 and here our value will become 1. Still our array is not sorted, so again we will check for this one. So this one if I put at this place, so our array will be sorted. So I have to check whether this place and this place is 0 or not. Only then I will be able to swap the element. So I will change it to 0 and change it to 1. Okay, let me explain it again. So your current array is 0 1 0 1 0 1 double 0 1 0 1 triple 1 0 1 triple 0 1. Okay, 0 1 2 3 4 5 and 6, and here 0 1 2 3 4 5 and 6. Now what will be the sorted version of this array, which will be 0 0 0 0 and triple 1. Okay, but since our array is not sorted currently, so what we actually want, we want that all ones should be moved to the right side and all zero should be moved to left side. Okay, but how can we achieve this? So firstly we will check that is at position 1, is it 0? Yes. So and at another position also, let's say we want to put here, so we can do only if our frozen values are 0 only. If here it was 1, then we could not swap this element. Okay, so having this value as 0 is compulsory. Okay, so our value is 0. So here is 0 and here it is 0. So it is a positive case. So we can swap the elements, 0 here and 1 here. Still our array is not sorted, so again we will check if we are able to sort or not. So here it is 1. Okay, so check this value with this value, and here also frozen of value is equals to 0 only. So we can swap. It is a positive case. It is 0 and it is 1. So since our array is sorted now, so we can return true. Is the question clear now? Okay, I repeat the question. So what I want to say is you are given two arrays, array and frozen. Both will be binary numbers. Okay, and your length of both arrays will be same. You have to swap the elements in both the array. In this array, you have to swap the elements only if frozen of I and frozen of j is their value is 0. We want to determine whether the array can be sorted in ascending order or not. Okay, do I mean? What do I mean? Let 0 1 0 1 double 0 1 and 1 0 1 triple 0 1. I want to move all the ones to the right side and move all 0 to the left side. So my array will be look like this at the end. 1 1 1. This is our sorted array. So we want to determine whether this array can be converted like this or not. Okay, but there is some condition that if you are swapping some elements, let's say you are swapping this element and this element, but so their frozen of I and frozen of j should be also equals to 0. If this value is 1, you cannot swap any element with this index. Okay, got the question? Okay, so how can we achieve this? Okay, so let's take another example in which we will not be able to sort the array, which is 10101. 10110 10. In this, we want to move this element index to here. Can we move it? Can we move this one to here? Can we move this element to the right? No. Yeah. Why? Because here our frozen value is 1, so we cannot move to right side. Okay. So that's why what should be done? False. I hope you are now understood the question. So let's now understand the approach. Okay. Okay. So let's take the example again. 1 1 0 0 0 1 3 1 0 0 1 0 1 0 1 and 1 0 1 triple 0. Okay. So what we have done is we have taken the count of 0 first. 0 0 1 0. Okay, 0 1 2. I have done the indexing. Now what we have done is I have taken the count of zeros. Okay, in the array. What are the total number of zeros? 0 1 2 3 4. 1 2 3 4. Okay, now I will iterate now in my array here, and we'll check if my current index, if my I is less than the count of zeros, and if my array of I equals to 1 and my frozen of I equals to 1, so we will negate the value. Why? We are putting the negative conditions in our for loop. Why? Let's say if your current I value is 1 and your frozen of I is 0, 1. Here instead of 1, if it is 1 0, so will you be able to swap the element? No. So here we will return false. Okay. So one case is this. Another case is this, that let's say you are now at this part of the array. Okay, at this part of the array, and if your value is 0 but your current value is 1, will you be able to swap the array, swap the elements? No. So what you will return? You will return false. That's why I have put the negative conditions here. And why I have taken the count of zeros? So count of zeros is here 4 zeros are there, right? So here 1 2 3 and 4, 4 zeros should be here. So currently our value will be till the count of zeros, and later on 1 1 1 will be there. So because of this we have taken count of zeros. Understood this? Okay. So what I have done this, that I have taken the array of size and the count of zeros. Whatever the count of zeros are there, like in the array, equals to 0 1 0 1 double 0 1. So my count of zeros is, count of 0 is 4. So 1 2 3 and 4. Okay. Now why I taken count of zeros? Because in the first part of the array I want initially zeros, and then after that I want ones. So initially I will count the number of zeros. Okay. Now in this part of the code I will try to negate my code. How I'll try to make the negative code? I will check if I is less than count of 0, means I will iterate in the first part of the array. Okay, then I'll check if my current value is 1 or not. If it is 1, it means I have to swap it. How I will able to swap it? If frozen of I equals to, I will able to, if it is 0, but if it is 1, I will return false, that we are not able to swap it. I have previously one taken example, right, where if your array value is 1 and your frozen value is also 1, you will not be able to swap. So here only I have written that. Okay, after that, if your array of I equals to 0, let's say you have to swap with this element, and your frozen value is 1, will you be able to swap it? No. Okay, so you have to return false there. And if after completing the loop, if it does not return any false any of the time, we will directly return true. Okay, understood? Okay, any doubt? But can we move to the next question? Okay, then let's move to the next question. Next question is subsequence or pairs. Okay, subsequence or pairs. Sequence or pairs. Okay. Okay, let me take the question. So you will be given integer array in this question, subsequence or pairs. Out of all possible non-empty subsequence, you need to find the number of pairs of the subsequences whose bitwise XOR are equal. Okay, so first let me tell me what do you mean by non-empty subsequence? Means there is some value in this subsequence, and the question itself says that all possible subsequences. What does the first thing comes in your mind when all possible cases you have to find? What does the first thing comes into your mind? It is recursion. Okay, when you have to generate all the cases, all possible cases, so recursion should be the your first choice. Next, what the question is saying that you have to find the number of pairs whose bitwise or XOR are equal. What does that mean? You have a subsequence, let's say A and B. Another there is subsequence name C and D. So you have to count the number of pairs where A XOR B is equals to C XOR and D. You have to find the number of such pairs. Understood the question? Okay. So let me repeat the question if you have not understood. You are given an integer array. Out of all from that array, you have to generate all the subsequences. Okay, generate all the subsequences, and you have to count the number of pairs in which the XOR of first subsequence is equals to XOR of second subsequence. Okay. So let us take one example. So our array is 1, 2 and 3. Okay. So what are the combinations in this? 1, 2 and 3, 2, 1 and 3, 3 and 1 and 2. Okay, so these are the combinations. So whatever the XOR of 2 and 3 will be equals to 1. That's why what is the XOR of 1? Here it is single value, so its value will be 1 only. And 2 and 3 XOR is 1, so that's why they are equal. Here the value of XOR is 2 and here the value of 1 XOR 3 is 2. So that's why these are equal. Now here the XOR value is 3 because single element is there. So here is 3 and 1 XOR 2 is 3. So that's why they are equal. Got the question? Okay. So how will you move forward in this question? You will make a choice diagram. Like if you are on a current index and you have a current XOR. Okay, so this is your current stage. In this, if you are on recursion, you can make two choices. Either you pick one element or you do not pick one element. If you pick the element, what you will do, you will move to the next index. And if you are choosing the index, then you will do current XOR with XOR and array of IDX. Otherwise, if you do not pick the current element, what you will do, simply move to the next index and your current XOR will be as it is. It will not update. Okay. So this is what the question is saying. But since this time you have to find the number of pairs. Find the count of pairs. Count of pairs whose where XOR of subsequence A is equals to XOR of subsequence B. Okay, so that's why since we have to find calculate the count also, so we'll make a map also this time. Okay, we will take a map and we will take a count here. We will take a count with 0. So every time we take a XOR, we will increment our count, and whenever our index is equals to our array dot length, so we'll check if count is greater than 0. Why we are here? Okay, let me take this to our white screen. Okay, so what is this? So here you have pick one element or do not pick one element. Okay, but this step is crucial. What do you mean by count is greater than 0? Count greater than 0 means it is a non-empty subsequence. Non-empty subsequence. So if it is a non-empty subsequence, increase its value in your map. Okay, so this is the step in which we will do map of your current XOR plus plus. So using this, you will increase the frequency of current XOR. Okay, so I hope you are aware, understood the recursion part. Okay, let me explain the question again. You are given a question array 1, 2 and 3. You have to find the number of pairs pair subsequence. You have a subsequence A and subsequence B. you have to check if subsequence A XOR value of this value, this subsequence, and XOR value of this array is equals to or not. If it is equal, you have to increment your answer. Okay, so you have just have to count the number of pairs. Okay, so if you have to find the number of sequence, what can be subsequence of 1 2 3? It can be 1, it can be 1 3, it can be 1 2 3, it can be 2 3, it can be 1 2. Okay, so these are all your subsequences, or your subsequence can be 2, or your subsequence can be 3. Okay, so how to generate, first of all, how to generate subsequences using recursion. You pick an element, you're on current index. Okay, so you pick an element or you do not pick an element. If you pick the element, you will move to the next index, and if you are picking it, then you will make a XOR of it. So current XOR and your array of IDX. If you do not pick the current IDX, then just increment your index and current XOR will be as it is. Okay, this is main crux of the problem. Another main part is, another main thing the question is saying, that you have to find the number of pairs. So if you want to find the number of pairs, so what we have done is make a map, make a frequency map, and store the count of XOR, current XOR, and you will able to make the count of current XOR only if your count is greater than 0. If your count is greater than 0 means it is a non-empty subsequence, means you have find one non-empty subsequence. Okay, after that, after you have gathered a map, let's say you have first value is 1, its count is 2, another value is current XOR is 2 and your value is 1, another XOR was 3 and your value was 2. Okay, so if let's take an example, if there is an array 2 and 2, so how many pairs this 2 will be able to make? Yes, so this 2 will be able to make its count, like let's say count of 2 is 2. Okay, so it will be able to make the number of pairs 2 into 2 minus 1 upon 2. What if you want to find how many pairs a current number is making, so it will be n into n minus 1 by 2. So here it is making one pair. Okay, with the other pair, so this is one pair. Okay, so let me understand, let me explain this also. Okay, so after your hash map is, your map is complete filled, you will iterate in the frequency map and you will take the count of the every XOR. This is the count, let's say 2 3 4 anything. After that you will count the number of pairs using the formula n into n minus 1 by 2. Okay, so using this you will find pairs and add it in your answer. Okay, at last you can return your answer. So the main part is, the question was first generate all subsequence using recursion. After that, fill the frequency map, fill the frequency map and generate your answer. Okay, so this was your code. You can see if you want to see the code. This was your second question. And in this, one important point is you have to take the mod also. Its question itself is saying since the answer can be very long, you have to take the modulo every time you are adding in your answer. Okay. So let's go to the third problem. Okay, why mod twice? So first we are, okay, the point is answer equals to answer plus pairs mod and then here mod. So the first mod we are doing is with the pairs which we are getting from the map, and second mod is we are doing for adding in the answer. So that's why we have done the mod two times. First is for pairs which we are getting from the map, and second one is for adding into the answer Okay. Okay, now third problem, which is the final problem. Okay, so the question says that k palindromes. So you will be given two integers k and n, and a string is considered a k palindrome if first it is a palindrome. Second, each character in the string is one of the first k lowercase English letters. For example, the lowercase alphabet characters for k equals to 4 is A, B, and C, and D. For example, let's say you are given k equals to 3. So in that string, you can either use A, B, or C. If you are given k equals to 2, if you are given k equals to 2, you can use only A and B, the first k characters of English alphabets. If k equals to 3, you can use A, B, C. If k equals to 1, then you can use only A. Okay. If k equals to 4, A, B, C, D, and okay, last only till D. Okay. Now, how do you form the k palindromes? First, the shorter length of the string will come first, and your string must be settled in the lexicographical order. Okay. So this is how you have to construct the string. What is the task? You will be given n also. So our task is to find the nth palindrome. Nth palindrome. Okay. So you are given k equals to 3 and n equals to 5. So first we'll start with A, then you can use B, then you can use C. Okay, till now we have completed K. Now we will start using another string A and A. Okay, and B and B. Okay, so first, second, third, fourth, and fifth. So this is our fifth string, which is K palindromic in nature. Okay, got the point? Yeah, you can do one mod also. It will work, but it is a suitable if you do the mod twice. You don't know like that how much. Hmm. We don't know that how much greater the value of pairs will be. If it is, this value will be very large, that so for that we use, for safety purpose we use mod here also. And for if answer plus pair value is very large, that's why for that we use mod here also. If pair value is very small, then no need to use this mod here. Okay. Now let's take another example for k equals to 4 and n equals to 5. Okay, so what the answer will be in this case? Okay, so let's figure out using the algorithm only. So what we will do is, we will be given k equals to 4 and n equals to, let's say k equals to 3. Take the example k equals to 3 and n equals to 4. So what we'll do, we will first decrement the value of n to 1. N minus minus. Why? Because we will find using the zero based indexing, it is easier for us. Okay, so first decrement the value of n to 3. So if you are let's say you have get, okay, let's say here you get x y z w 0 1 2 3. It is the same thing. If you find n equals to 3 or the fourth nth value, it is same. Okay, so that's why I have decremented it once. And we will take a variable L length with initialization to 1. We will take the first string with L equals to 1. Okay, so we'll take L equals to 1 and we will check k power L plus 1 by 2. It is for making the string palindromic. Why I taken L plus 1 equals to 2? Because we will first construct the second half of the string, first half of the string, first half of string. Okay, so let's say you have a string, let's say double A. If you construct this part only, and after that if you take the reverse of this string which is AA and concatenate these two strings, you will get a palindromic value. Okay, so our first task is to make the first half of the string. Okay, so how we will do this? Every time from n we will reduce the k power L plus 1 by 2. Okay, till the time we have a value greater than equals to 0. Okay, till the time it is greater than equals to 0, we will increase our length also, that every time our length is increasing, and we are decreasing our value of n also, that how much time we have to perform a certain operation. Okay, so while this is equals to greater than equals to 0, so we will subtract n minus equals to n equals to n minus k L plus 1 by 2. Okay, and next time other than that we will do L plus plus. Okay, so after we have increased the length, next time if our n is greater than 0, that means we have still some operation left. So while n is greater than equals to 0, so we will we'll start adding the characters into our string. How? First n mod k, using n mod k. Let's say you have a n equals to 1 and your k is 4. So 1 mod 4 will be 1. And what is the 1th value in our English alphabet? Which is b. So our current value of string will be b. That's I have taken just a case that how we will add in the answer. And every time we will again we will start decreasing the value of n. Okay, so we will do by n mod divide modulo equals to k. We will divide it. Okay, and after that we will reverse the formed string. Reverse the string so that we can get the mirror image. Let's say if you have a string AB, if you have the mirror image of the string which is BA, so it is a palindromic string, and if your k equals to 2, so only A and B will be used for it. Okay, so let me explain you by taking example along with the code. Okay, so let's say we have k equals to 3, 3 n equals to 5. Okay, so you will initialize your length will be 1, where that you have initially a string of length 1 and decrement your n to n to 1, and with 1 that will be 4. Now you will start coming here that you start decreasing your value of n to 0. Okay, so at the first point we will check if 4 minus your k is 3 power 1 plus 1 by 2, which is 4 minus 3, 1. It is greater than equals to 0? Yes. So we will decrease it. Okay, so we will decrease it. K power L plus 1 by 2, for n, here n will become 1. How? N minus 3. This value will be 3 at the time. So it will become 1 and your L will be 2 now. Okay, now at the second time, now we will check if your n, which is now 1, 1 minus your power k. What is your k? 3 power L is 2. 2 plus 1 by 2. 1 minus 3. Is it greater than equals to 0? No. So we will come out of this while loop. Now we will take a string, empty string. Okay, so while our n is greater than 0, our n is 1 till now. Okay, so while our n is greater than 0, we will concatenate characters in our string. What will be it? N mod k. What is n? N is 1. Mod k is 3. 1 mod 3 is 1. So a plus 1, its value is b. Okay, so our current value will be b. After that we will check that if our 2 into string dot length is less than L or not. Okay, so our L is 2 and 2 into string, our string length is 1, so 2 into 1 is not equals to not less than 2, so we will not go in this while loop. Now comes the second part where we will add the second part of the string, that is AA and AA, this mirror image. So we'll take a string t which is equals to s, and our s is b, so currently our string t will be b. Okay, now reverse that. For example, let's say you have b and you want to make it palindrome, so what will add? Ba. Okay, now s plus equals to t, b and b, and return your string. So this is your answer. Understood this? And why we have done this? Because if our length is odd, so we have to make it even, so that's why we will use a pop back also. we will remove a last character of our string. Okay, so this was the third question. You can see the code. First, we'll start initializing L with 1 and decrement the n with 1. Now, start decreasing the value of n till it is greater than equals to 0. Okay. After that, we will initialize a string, and till n greater than 0, we will start concatenating the characters to our string using n mod k, and we will divide the n by k every time. After that, we will make the second string, which is the mirror image of that string. Okay, by reversing. Let's say A, B, and then we will add the BA in the last. Okay, at last, I concatenate both the front and second string and return it at last. Okay. So any doubts? Okay, then these were the three questions which were asked today in the Job-A-Thon. Okay, so yeah, let's meet with the next solution. Till then, keep practicing. All the best. Thank you.